grade 2.3?
I never got 2.3.
Ah, lame sauce. All right, 2.3. It's short though. It's short. It's short. 2x squared minus 4x plus 3. It went in perfectly. It went in perfectly. Number 30 did not go in perfectly. The remainder was 199. If you got 199, you probably got the rest.
What number is that?
Number 30.
I did not get that.
Wait, 30?
This is number, sorry, I don't know what number this is. 14. You're going to see in multiple places on the answer key x not equal to, because as soon as you divide, the denominator disappears, but the 0 was never allowed. So you're allowed to divide and say, this is the exact same thing, and isn't this so much prettier than that? But domain problem, I have to say the 2/3 stays as a domain problem. So it's kind of like, yeah, denominator's gone, but there's still a domain problem. So it's like this little extra PS, I know the denominator's gone, but. Sorry, remainder of 199 for number 30. You guys got that one? Okay. Number 40 and 60, and then we're done. I think that's the last even. So number 40 goes in evenly, but check it. They did that whole x not equal to 9 thing again because the denominator disappeared. X squared plus 9x plus 81. KJ. 14, like 1/4? Hold on. Real quick. Here you go. 2x squared minus 4x plus 3. And then x can't equal 2/3 is just saying what denominator is illegal. Is that good? Sorry. Back to 40 and 60. Yeah. Because look at your remainder. There's still a denominator where the x can't equal -6 is implied. Does that make sense? So we only need to state that whole x doesn't equal if all denominators are gone, which only happens when it goes in evenly.
So if synthetic division, if there's a remainder, that remainder goes on top of x.
Of the factor, yeah. And then number 60 goes in evenly, and so they went ahead and said, hey, I divided by, Alec, shush, divided by x plus 4, and that's why x plus 4 is a part of this factoring at the bottom. So they divided by -4, aka x plus 4. What's left, and then they factored that to finish it off. Yeah.
So for 60, I just plugged it in.
Yeah, I plugged in -4.
Because at the time I didn't know how to do synthetic division too.
On 60?
Yeah.
What was it asking on 60?
It said like x cubed minus 28x minus 48.
Oh, I'm on the wrong homework. Sorry, guys. It's on the next page, right?
Which paper are you using there?
And then it's just like x equals thing.
Oh, I see. Okay.
We can get more, okay.
Okay, shh. You can as long as you stay quiet when you do it. Shh. Thank you. Number 60 was really weird as far as what they were asking. So if you did plug in Laurel, you would have gotten 0, right?
Yeah.
And if you got 0, what that tells you is ding, 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 I can divide. Because it'll go in evenly. And so that's when you would take the -4 because you got 0 and do the division.
On quiz, if you see that our work is not synthetic division, will you take off?
The dilemma is without synthetic division, I don't know, here check out the answer key again, I don't know how you could have gotten the factors. Does that make sense? Because with the synthetic, it's all of a sudden possible to say, oh sweet, a quadratic I can factor. So it's, I would have definitely given you points for the work, but at this point, what you were trying to do was the factoring, and synthetic makes factoring possible.
So after you find out that it checks out and it's 0, then
you throw it in the box.
But then what's all your work with the factoring?
Well, you throw it in the box, and when you throw it in the box, you say, okay, you go in evenly how many times? That -4, remember, it comes from x plus 4.
The x plus 4 stays.
Exactly. And then how many times what's left over? Got it. And then we break him down.
Okay.
See it?
Yes.
So once we know the negative 4 goes in, that's perfect. We know that he is one of the factors. Synthetic tells me what's left, and that what's left, I go ahead and factor with that. So. Sorry, hold on. Can you say it a little bit louder?
Actually, I think I'm not.
No, well, go ahead and say what you're thinking, though. Maybe I can figure out what you're talking about.
What's the formula? Like, you know, like, difference of
A squared minus B
yeah,
squared.
isn't there one for the
Is there a perfect cube? Oh, this guy. Yeah. There is one for perfect cubes. We'll go over it in section 2.5 when we're doing polynomials. But yeah, there is one for perfect cubes. It has to do with cube rooting this, which is x, and cube rooting that, which is, no, not 13, that's 169. I think it's 9? It's 9. So cube rooting that is x, cube rooting that is 9, and so it's going to be x minus 9. It's either plus or minus depending on what's here. And then you have the cubed root squared plus the cubed root times the cubed root, 9 times x, plus the cubed root squared. It's a lot harder than a squared minus b squared, yeah. It is possible, it is a thing, but we'll look at it later. 2.4, you guys ready? This one should be faster to grade. Number 6 is complex conjugates. Yeah. Huh?
I just saw conjugates in the. I saw that.
I think conjugates is just because of. Hold on, sorry, I keep on switching back and forth because I forgot we were grading 2, 3. What number is this? Number 6? Okay, they are complex numbers, but the relationship to each other is conjugates. Does that make sense? So yes, you're not wrong, but the relationship to each other is what they were trying to talk about, is technically conjugates. Number 8 should have just been A is 13 and B is 4. Which that one was nice because it's like, hey, but it was number 26 a little bit. Oh, not 26. Did you guys have an odd that was a little bit harder? Was number 9 a little bit harder? Yeah.
Number 9 was big brain.
It was great though. Did you guys figure it out? Okay. Yeah, just. What would you do, Laura? Good, because A minus 1 had to make 5, right? So A had to be 6. So basically you're doing a system of equations, if you guys could see it, because the real A minus 1 had to equal the real 5. And the imaginary B plus 3 had to equal the imaginary 8.
What about the I on the outside? Does it mean anything?
Well, it tells us like which category. Real had to go with real, and imaginary had to go with imaginary. Like A had to go with 13, and B had to go with 4.
Oh, okay.
See it?
Yeah.
But those of you guys that are too used to like solve for x, solve for x, solve for x, you would have gotten so confused.
Oh,
but some of you that have just more of a logical approach to math and natural problem solving, you might have said, oh, that's easy, that's 6 and that's 5. Sophia. Section 2.5. The blank is open because I don't know. You have to see. Number 26, though, that was just subtraction. Did you guys kill a seal or did you do it correctly?
Let me see.
Number 40, did you kill a puppy or did you actually foil and simplify?
nobody's dead.
Hopefully not.
Nothing.
Nothing, yeah. I guess we shouldn't call animals people. Oh, was that not yours?
No.
Oh, what was your guys' homework?
53 and 69.
Did you guys have any other evens or was number 52 the last one?
72.
72. Okay, let's go check out 72. Sorry, this is pre-calc. I was just too lazy to open up the normal. So number 72 and 92?
90 was extra credit though, and no one did it.
It was easy. I did it. Oh, okay. So you read the directions.
Oh, quadratic formula.
I'm
Really? That's nice. X equals negative b plus or minus root b squared
How about negative?
6 minus c,
Have it
which is
near.
negative 4 all over 2, which would be negative 6. Alex. I'm done competing. Drink your coffee and enjoy it quietly. All over 2. Coffee shops are nice and quiet. Divide by 2, negative 3 plus or minus I.
Plus or minus? Project.
Which from?
How do you end up getting an I? Like in that at all?
Whenever I square root a negative number.
Mucho confusion. So the negative 1 squared counts as an I. And then,
The only way to square a negative
okay, and
number is
then your negative 4 came from what? Like
Oh,
in the first place?
30, b squared, 36 minus 4 is c minus 4.
36. Okay, 36 minus what? Ooh, minus 40. Which is
Sorry, guys, help me out with the evens. That was 72, and then you said 92 and 96?
Oh, 98.
Oh, no other 9. Oh, 98. Do you want to peek at it? We can peek at it. I don't know.
Well, what was the answer to 72 again?
It was, negative 3 plus or minus I.
106.
Oh, it's one of these ones. I like this one was. Maybe you didn't do the extra credit, but let me show you how easy it would have been. Because they say that we put the real numbers on this axis, so the reals are x's and the imaginaries are y's. So you look at things like this and you say 3, isn't that 3 plus 0 I? Yeah. So wouldn't that be the point 3 comma 0? Ah!
Oh, wow.
Yeah, right? Now, hold on, who's this guy? 0 plus 3i, so it'd be 0, 3. That one. 4 plus 2i. Oh, that's 4 and then 2. 2 minus 2i. Negative 3 plus 3i. And negative 1 minus 4i.
Oh, you do? Is that 98?
Yeah.
Oh, that's fine.
All right. Here we go. Section 2.5. Oh, okay. You know how we were talking about that whole we might not get everything done today thing? I think what's most useful right now for us to do is to get into section 2.5. I can't talk to you. So that you guys can tackle homework out.
Is it due
And we'll go.
tomorrow?
Like it's empty.
Sorry.
Let's get into section 2.5 so that we can get as best of an idea as possible in this section. I can see how far we can get, and then we can go over homework questions tomorrow with 2.5 probably being due on time. Sound good?
Oh, that'd be great.
Okay. We'll
Thank
see.
you.
We'll see.
Can we ask you how we have things in the back of
Oh, okay, so we're going to our notes. If you guys have any burning questions at this point, I'm going to peek at number 61 real fast, and then I'm going to take any other ones from either of the sections at the very beginning of class, because we won't be doing copy, we will be focused. Oh dear, that's not even homework. Where's number 61? But someone had a question. Claire, did you have a question too?
Yeah, can you do it?
But don't worry, you know the calendar and you know YouTube videos and PDFs of notes online, right? Yeah. Perfect. Okay. Guys, what's your advice on this one? No.
You can't do it
Why?
because you need the same denominator.
Can't do anything until we get a common denominator.
Oh, yeah.
And the only way to get a common denominator is this guy needs him. Just because it's the other dude and this guy needs him. So it happened to be the conjugate, but it's not always, right?
They need each other.
It's not always the conjugate. Just this one, we ended up multiplying by each other because we had to get the common dude. So then we end up with, careful, I'm going to rewrite it this way so I don't kill a seal. I'm going to do the negative on the outside. But don't just say the turtle, say all the woodland creatures. Oh, I guess turtles aren't woodland creatures. So 1 minus negative 1 would be a 2, and then we can distribute 2 minus 3. Negative 2i minus. But we don't stop there, do we?
No.
To get a complex number, don't we want to look like this?
Yes.
So what do we do whenever we have a denominator?
1/2 minus 5, 2.
What's that called? Well, I call it the heart method. Period 6 calculus kids have started calling it like the butterfly effect. I don't know. I don't know. It doesn't really make sense to me, but that's okay. I saw a heart and they saw a butterfly. That's okay. But then you could also say distributing the division. Or distributing the multiplication of the reciprocal. Either way, it's basically distribution. Does that make sense? You're trying to figure out why it's a butterfly. I don't know. Ask Tyler. Tyler and PK. Yeah. They're cute. I don't know. Shh. It's okay though. They remember it. The point is that they remember it. We like when they remember things. You too? Okay, here we go. So what's going on in section 2.5? Yesterday, we were able to write down one page. We were saying things like, hey, how many zeros? And I was like, oh, according to the degree, there should be a max of 1, a max of 2, and a max of 3. But then it said, that's weird. I was saying earlier, like with quadratics and with polynomials, a max of, but what does this question say? Just how many? So that's interesting, because then we have to go find the zeros, right? Said equal to 0, that was easy. Said equal to 0, okay, factor, that was easy. Said we were supposed to have 2. Did we have 2? Yes, it was just at the same place. So we did have 2, it's just 1 with a multiplicity of 2. 2 coming together, and okay, it's 1 point, but it's technically 2 zeros, or a repeated 0. A repeated 0, a 0 has been repeated twice. Oh, so maybe there's a little bit of a extra understanding as to what this number could be. Multiplicity of 2. How did this one have 3? That one was a 0, a real number. Check. There's 1. This one is, wait, can't we not do square roots of negative number? Oh, Jaden, here you go. Do something. If we set this guy equal to 0, wouldn't that be a negative 4 being square rooted? But now that we've done section 2.4, don't we know what to do with a negative 4 being square rooted? Can't we use i's to help us out? So do we have 3 zeros? Yes. But guys, how many would you see on the graph? Just 1. Because those are imaginary. They're not going to show up on a real graph. Real x's, real y's. How many would you see in this one? Just 1. But there are 2 factors. In this one, you would just see 1, but technically there are 3. Just 1 real, 2 are imaginary. Okay. So the definition of zeros has kind of changed a little bit. We're not just looking for real numbers. We're also looking for complex numbers. And the big picture is we're going to have to factor to get there. And if you guys notice, you're a GCF. Good thing we're the Big Brain Club. Good thing my computer's not working, because you guys might not be able to see it. This is x to the 4th minus x cubed plus x squared. Oh dear, minus 3x minus 6. How the heck can they be asking us to find the zeros? What? Maybe we should think of this. Maybe we should think of this. Priyanka, I'm coming back to you in 1 second. But first of all, I need to at least get you guys started on finding our list of, ready? Possible zeros. To find the zeros, I really hope there's some way of having a category of possible zeros for us to even look at. Because if I just ask you what are the zeros, technically right now you're like, well, there's infinitely many options. Great, thanks. I don't know. But if we can narrow down those infinitely many numbers in the number system to maybe a few to check. Let's talk about how to check them. But first of all, the few. The few say, look at the constant term. Who's the constant term in this one?
Yes.
No. The constant, not the variables, but the constant term. Over the leading coefficient
1
term. So guess what the possible zeros, ready? Possible. We always should start with the possible zeros before we go looking for them. Let's narrow down. Let's make our job easier. What are the factors of 6? Well, plus or minus 1 or 2 or 3 or 6. Do you have any other numbers, whole numbers that go into 6?
3 and 2 and 1.
Any other?
Wait.
No. We have 1 and 2 and 3 and 6, right? It's okay. I should have asked you first before I wrote it down. But yeah, we have 2 and 3 or 1 and 6. Now pause. Here's the nice one. Here's the nice one. Here's the nice one. How many factors of 1? 1.
Very good.
So what are our possible zeros? Well, plus or minus 1, 2, 3, and 6. Because okay, just divide by 1. The butterfly, the heart, the whatever you want to call it. Bianca, what's up?
in this class.
You're fine. You were right. Yes 2, yes 3, yes 1, and 6. Yeah.
I was just asking if imaginary numbers don't show up on a real graph, then what are they?
Give it something.
Real fast. Imaginary, real. Imaginary, real. I want you to switch imaginary and real. Every time we say imaginary, say off. And anytime we say real, say on. Off.
On. On.
Oh, sorry. Off.
On.
On. Why are you saying switches? Great word. You don't know.
Because
With
light
circuits,
switch.
with electricity, with binary code for computer programming, zeros and ones. If you know what any of that means, there are times when we want it off, and there are times when we want it on. Maybe imaginary numbers are way. Just to give you a hint.
It's the matrix.
No, it's not.
Oh, shoot. How did no one in HPrecalc? They knew what we were doing. We wrote it well in our
We did it recent. I should give them.
Nicely done. Or do you want to keep that?
Ricky there with.
Can I Kit Kat? Ricky loves Kit Kat.
Stop. Pause. Before I get Emily her love Kit Kat. We need to test the zeros. Because all we have right now are possible zeros. But that wasn't what the question was. It's not finding the possible, which some homework might be finding the possible. Yay, we're done. But hold on, pause. Ready? What if I was to start doing this?
Oh my goodness. Oh.
Now pause. Pause. Pause.
That really
This is a 4th degree polynomial. Pause. I'm not about making more work. I'm about finding shortcuts. So calm down. Think about that. This is a 4th degree polynomial, which means what are the maximum number of zeros we'll find? The maximum number of real zeros. Some of them might be imaginary. We'll see. 4 zeros. 4 factors. So first of all, do I have to really do all 6 of these? No. What I need to do is find one that works. And then last night in homework, when you plug in 1 and it gets 0, it works. When you do a synthetic, the remainder is 0, it works. When you find one that works and we divide, what happens to the degree? Did you notice?
It lowered by 1.
It lowers, and all of a sudden we only have to look for.
3 degrees.
And if we find another one that works and we do division, then all of a sudden we have a quadratic, and all we have to do is factor the quadratic like we know how to do. So we really just need to find 2 that work. Now, some of your brains are like, plugging in is dangerous for me. I don't want to plug in. I would rather, oh, hey, in section 2.3, didn't we learn there was another way than plugging in?
Completing the square.
Could you, no. Could you do synthetic for every single one? Yeah, plug 1 in the box, -1 in the box, 2 in the box, -2 in the box, 6 in the box, -6 in the box. But if you were good at mental math, couldn't you know what's going to happen in the remainder box by plugging in 1 minus 1 is 0, plus 1 is 1, minus 3 is -2, minus 6 is, that's not 0, forget him.
Bruh.
If you're good at mental math, you can look at what's going to be the remainder and say, well, you're not going to help. We're looking for zeros, whether by plugging in or whether by doing synthetic. We're looking for zeros, whether by plugging in or whether by doing synthetic. So if you're mental mathers, now I'm putting positive numbers on front because I don't know about you, but my brain does better with positive numbers, especially in plugging in. I make mistakes with negative numbers. But that's just me. So some of you might be like, that plugging in thing, I kind of liked how you just plugged in 1 really fast and realized it didn't work, so you didn't do synthetic. That's nice. So maybe you would go to plugging in -1, or maybe you're scared of negatives, you go to 2. Either way, could you plug in? Yes. And you would end up with 2 to the 4th. You guys ready for my trick? 2 squared is 4, 2 squared is 4, and 4 squared is 16. That's a nice one. 2 to the 4th is 16. 16 minus 8 is -8. -8 plus 4 is -4. -4 minus 12 minus 6. Ooh. I'm not sure any of those positives are going to work. I think eventually we're going to have to go to negatives. But what I'm seeing is by plugging in, not 0. What I'm seeing by plugging in is not 0. But just for sake of argument, let's throw one of these guys in a box. Because you could have been doing synthetic. What would happen on both of those is the remainder would not have been 0. So forget them. They're not helpful. But let's try -1. Plus, I don't like negatives. I get mixed up a little bit. Let's throw in our coefficients of 1, -1, 1, -3, and then -6. Uh-oh. Our remainder needs to go down here a little bit. Okay. Got him. Oops. I was doing my adding. This one's going to be a bit wrecked. Okay.
How about news?
Woo! There he is. What did I just figure out? That's a go.
Oh, yes.
Oh, did I not write them down? I got lazy and I stopped writing. I was going down.
Yeah, he would
Wouldn't show us anything else.
Yeah, he would just give the answer that he would not show the work at all.
You're assuming I didn't know the answer. But I do show my work.
Well, like, he did not show his work.
But pause! What did we just do?
Synthetic division.
We found a 0. What was the goal of the problem at the very beginning?
Figure out which ones work.
Figure out which ones work, right? I'm going to go single page because I'm just tired of running everyone. There we go. I'm trying to find the rational zeros. So right now I know there's one at x equals -1, right? But how many more theoretically am I looking for? 3. But why did my job just get a little bit easier?
Now you have a trinomial.
Now I can use my trinomial and say, okay, let's break you down. Now, here's something nifty with synthetic just because you're honors. Probably won't show regular this, but just because you're honors. We can actually do a synthetic, ready, right here.
Oh!
Because we're going to break him down. Now we could also write the polynomial and then keep on going on our journey of plugging in stuff.
No.
We could technically plug in a -1 and say maybe there's more than 1. Or we could go try in someone else and say, because remember, just because he happens or works once doesn't mean he doesn't happen or work twice or 3 times. Or we could just go to a new number and say, how about -2? What do you guys want to do? Try -1 again, or try -2 or 3 or -3 or 6 or 3?
Let's try 3.
Try
Let's
3?
try -6.
Oh no, you know the answer.
Let's try -6.
Sorry.
My brain is
If I
too
told
big.
you all the answers, you would never learn. If we try 3, are you guys okay? It's a positive number. I like plugging in. That would be 81. How'd I do that? Because 9 and 9 is 81. Sorry. 81 minus 27 plus 9. I don't think that's going to be the answer.
It's too complex.
We could try, but 81 plus 9 is 90. And 90 minus 9 minus 6 minus 27 isn't going to be 0. Let's not try. Let's go -2. Okay.
Yeah.
I don't like negatives. Let's plug in the box. You guys realize, though, we could be plugging in, right? Or we could be doing synthetic. Jake.
So when we put in the -2, does that mean we're really using 2 positive? Or how does that work?
What we're really testing as far as factors go is x plus 1 and x plus
2. Okay.
See it?
Yeah.
If we were doing factors.
Okay.
Lo siento, how are we doing? Let's see, that's a -4, and then we have an 8, and that's an 11, and that's a -22.
Maybe -1.
Okay, so, I mean, it wasn't bad that we tried synthetic. Some of you might want to erase, and some of you might just do like a X through and say, well, that didn't work, let's try again. Do you want to try -1 again? You can. Or we could go -3. Oops, my box should be a little bit higher. I'm making it real to your guys' search because you're going to have to be doing this, yeah? And it's going to not be nice and neat, new guessing the right answers every time. It's a bit of a search and rescue, a bit of a scavenger hunt, a bit of a trial and error. Did you guys match up with my 1, -2, 3, -6? Just because I make mistakes too. That was okay? Okay, thanks, Cassie. Oh, I already did that. I was just double checking my numbers were right, because double checking is always nice. So that guy was a failure. Are we going -3 or -1? -3. Okay, so -3. Let's check it. That's a 1. And then that'd be -3. And that'd be -5. And that'd be 15. And that'd be 18. And that would be -15. Izzy keeps saying it. Let's try it. So we have 1, negative 1, negative 3, 3, 6, negative 6. Oh, because Izzy thought that negative 1 might go twice. What's the struggle?
Small brain time.
I'm checking all my work because I thought the negative 1 was going to work.
It's gonna go too big. Yeah.
Are you wrong?
You did which one?
I did 2.
You did 2 and it worked?
Oh yeah, 2 should work.
Yeah, I already tried to and it worked.
Oh. Why did you guys tell me 2 worked?
Yeah.
Such small brain.
Hold on. 16 minus 8 is negative 8. Negative 8 plus 4 is negative 4.
No, 16 minus 8 should be positive 8.
Oh, I was saying negative 8.
Hell, GP.
Nice. Thank you, thank you, thank you. So 2 does work. I mean, the nice thing is you guys already checked it, so you knew. Yeah, I did the same mistake twice. Have you guys ever done that, like proofreading an essay or something? You look at the same mistake.
I was like, don't collect it.
So that'd be 4, and that'd be 2, and that'd be.
Oh my god, it works. 4.
See, so we need a small brain.
Oh, there we go. 0, and then 0, and then 3, and then 6. And then... Wow, that's a struggle. My skills are not so awesome today.
Oh, wait, why'd you put 2 4s?
2 4s.
I never lost.
Didn't you just, and then you,
Oh, because I multiplied them.
okay.
So that's an x minus 2. I think, Jaden, you were asking me that earlier, right? Now we have x equals negative 1, x equals positive 2. Well, who are our other guys? Let's take account of what we've done so far. We've figured out that f of x is equal to x plus 1 times x minus 2 times, well, who's left after all of this division?
Not X.
X squared plus 0, x plus 3. Oh. Oh, it's a quadratic. Guys, we can do the quadratic. We have to find the last 2. So how do we find the last 2 zeros?
Come to the seal.
Because we already did that one. We know it's negative 1. We already did that one. It's positive 2. Doing that one, wouldn't we end up with x squared is equal to negative 3? So x is equal to plus or minus rad negative 3. And Alec, now that we've done complex numbers, can't we say this is plus or minus rad 3i?
Yes.
Oh. Rad 3i is negative rad 3i.
How can we find that?
You can put the I in front. Sadly, they put the I back here because it's A plus BI. I is always at the end. But all I did, Bianca, is I just took my factor set equal to 0. Subtract the 3, square root both sides. Oh, it's imaginary.
You get the last factor.
Oh, remember? I took what was left. So that's a constant term, that's an x term, and that's an x squared term. So x squared plus 3.
So all of these problems are 15 to 20.
Well, not all of them are factoring completely. That's kind of like the end of the.
Okay.
Some of them are just like, hey, does this go in? Or what are the possible zeros? Or forget how else they do it. This is an answer, so start there and find the rest.
Why do you use like the
Alex.
answers for negative 1?
Well, I decided to use it because it was already all nice and written out, and I was like, well, I just need to break him down. I don't technically need to go back to the beginning, so it just made my work a little bit easier to have fewer numbers to work with.
But could you go
You totally could. Maybe. My battery, I think, actually is kind of dead and might not ever run again.
Oh.
You know how my batteries get that weird? I think that's. Wait a minute. What's the difference between these directions and these directions? What was this guy looking for, technically? Just the zeros. So technically, all he wanted, if I was to get a nice pretty box, because my writing was definitely nice and pretty there at the end, it was literally just asking for this. Wait a minute. What kinds of zeros was it actually asking for? Rational zeros. Aren't rational numbers like ratios, like real numbers? So technically, it was only asking for, those are the only rational zeros. Now, could other problems want all the zeros? And all the zeros would include all the complex zeros, not just the reals, but also the imaginaries. So other questions might want them all, but the beginning ones might just say, hey, take the possible nice rational zeros and see which ones work. Well, those were the only ones that worked. If you had gone through all of your different options, only -1 and 2 worked. But this one is asking for something very different, or maybe not that different at all. Because it's saying factor. Well, guys, didn't we get the factors when we looked for the zeros? So maybe all we need to think about is who are the possibles. Let's narrow down our list and then let's go for it. So the possibles, wouldn't they be plus or minus 1 and 3 over 1 and 2 times? Do you see where my 1 and 3 and 1 and 2 came from? I'm looking at the constant factors over the leading coefficient factors, and that's all I got. So then I have to do all the division and say, okay, well, hold on, who are my possibles? Well, I have plus or minus 1 over 1 and 1 over 2, plus or minus 3 over 1, and plus or minus 3 over 2. So I still have 8, but I have fractions. Oh. But remember, if I can find one that works, can't I break it down? Oh, if I break it down just once, won't I have a quadratic?
Yes.
Nice. Okay, so I only need to break it down once. Now we could go ahead and start with synthetic. We're going to want to use synthetic to break it down. But any mental mathers out there already checking out what happens if I plug in 1? If I plug in 1, if I plug in, I'm not sure if I would want to plug in the fractions, but I think I might want to plug in the whole numbers. Because 2 plus 3 is 5. 5 minus 8 is -3. -3 plus 3 is...
Yeah.
Ding, 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 ding. Found a winner already. Double check these up. I think one works, yeah? So then can I go ahead and do my 2 and my 2 and my 5 and my 5 and my -3 and my -3 and... Oh, maybe they're not all that bad. Because if I find one quick that goes in nice and even, my remainder is going to be 0, which means, well, you guys help me out. What can I say about f of x as far as his factors? Who's this guy? X minus 1. And what's left? This homework technically isn't due until Friday, but since we're moving to 2/6 tomorrow, I'm just giving you 2 nights to work on it. Sound good? All right. See you later. Hello? This is Mr. X, sorry. I missed you, right? She's in a different, she's not in my room. She's in a different room. So
Like
Mrs.
wrong
McCrae would be in like 140.
Like her own
Yeah. Oh yeah. I got distracted.
I should have made a good idea. Today I was like,
I live inside. You know,
Gee, right
Gee.
down the box.
You want to take out Reese's? You got me too. Take.
gee, how are you so smart? Gee, it's not great to share someone who's big brain. We both have medium.
Keep catching my mistakes.